Okay. So guys, hey, listen up as we get started here. We're going to be wrapping up. We're going to wrap up our packet here fairly quickly. So I won't see you guys tomorrow, but I will see you on Wednesday. Just because we don't have class tomorrow. Maybe on. Or sorry, we don't have purple on Tuesday. But when you do come to class on Wednesday for purple, we'll be doing our Unit 3, which kind of goes with Chapter 5 in your book, so you'll need a new packet. I did not think about it. You're welcome to look around.
Colin.
There's a water bottle. I found a pencil if this is what you're looking for.
No,
A wallet. No.
Why we just got here. Oh, look.
Where Logan is.
Did it have $24 in it?
Did it have what?
Because I definitely didn't.
It had like nothing in it.
They're just going to be messing with you.
It has my
If it had $100
ID.
in it,
Did
Brandon
it
would
have
no
an
idea what you're
Did you just run up
Yeah.
the stairs?
Yep.
Yeah. I don't think
It's okay, you can breathe hard, it's okay.
And I'm sorry, I did not pick anything up.
I know I had it before, right after
You
lunch.
ever do a test?
And I already checked my last class.
Oh, yeah, you walk
And I checked where I was sitting. I had it at lunch.
Did you check the bathroom?
Bathrooms lost and found.
I already went through lots of fun. It has my ID right there.
It'll get turned into the front desk if your name's in it somewhere.
If you open it up, my name's right in the front.
Yeah, okay, so it'll get returned at some point.
Yeah, same.
So
And if it doesn't,
Sometimes I'm like, oh, it's not in my wallet. And I'm like, find me. I'm like,
nice one, Jack.
Sorry.
get out of my wallet. I can't go anywhere.
Bye, Colin. Hope you find your wallet.
have a good day, dude.
Bye,
Thanks for dropping by.
Find your wallet.
Or not. Like,
Bye,
it's up to
buddy.
you, I guess.
Bye.
He had some tight pants on. Not gonna lie.
That is a fashionable man right there.
That guy has some tight jeans.
That is a fashionable man.
Yeah, dude, you're in the mood. I'm ready
Okay.
to go when you are.
Now that we have all that cleared up, or less clear than it ever was, let's see here. So, yeah, you want to have your Unit 5 packet ready to roll for Wednesday. And for veterans, Unit 5 is going to be a jumping off point. That's going to be, once we get past Unit 5, we're going to start doing a lot of brand new stuff for everybody. It'll be kind of a mix, but immediately after Unit 5, it's going to be into brand new for everybody, so everybody will be in the same boat at that stage. So I think that's kind of cool. We'll all be together. Anyway, so this is where we are here. Your Unit 2 test, which is on Thursday, similar formatting in that it very well could extend a bit into lunch, so be aware of that, be ready for that. Please don't show up on Thursday and say, I just realized ... I can't do this. Like, plan ahead. You didn't do this. You actually planned ahead a little bit, so be like Peyton in that regard and plan ahead enough to where you realize
Don't get it during lunch.
there's a conflict that you need to work through as opposed to, oh my goodness, it's the last second. That kind of thing. We don't want that. Okay, so let's wrap this up. From pre-calc, even functions are symmetric with respect to what? The y-axis. That's correct. That's a nice graphical connection. So an example of a lovely even function would be y equals negative x squared plus 4. This would look approximately like this. Oh, come on. Meg, are you going to stop talking anytime soon? Because I've been trying to teach and you have not stopped. Are we going to do this? I'm trying to be nice about this.
I was being quiet for the first part of class. That's the first thing I said to her.
Okay, well, anytime I'm feeling like I have to talk over someone for more than 3 seconds, I got a question. Sorry. I feel like we should be able to function that way. We should all just take our turns talking. Okay, so there's a graph of that. Y'all okay with that graph?
Yep.
It's it's beautiful on the left, not so beautiful on the right. So if I told you that the integral from negative 1 to 1 was 22/3, so we're talking about this region right here. what would you say the integral from 0 to 1 is? 11 thirds, right? It would be exactly half of that. That, of course, is based on the symmetry idea that you all said earlier. So you're right, of course, 11 thirds. General idea is that if you've got the integral from negative a to a, that should be double the integral from 0 to a if f of x is indeed an even function. So sometimes there will be opportunities where you're told, hey, f of x is even or f of x is odd. We'll get to the odd here in a second. And you're going to have to make judgments on that. There's not going to be like an analytical graph even like what I gave you up here. It's just going to be mentioning, bless you, that f of x is even or odd, and then we got to kind of go from there. I kind of like the graphical perspective, so if you can sketch out a graph, that's always a good thing. So then also, there are odd functions. Odd functions are not symmetrical with respect to the y-axis. It's symmetry not on the x either, because then it wouldn't be a function. It's the origin, yeah. So the origin symmetry, this one's a little bit harder to see. But I've got a nice one here for you. Sine is actually an odd function. And so sine looks about, let's see here, like this, and like this, and like that. So I'm going to say sine looks, I don't like that, like so. So I don't know if you can see the origin symmetry here. This is the classic look a lot of people will see is if you take some point here and then you reflect it across the x and then you reflect that across the y. Do you see how there's that symmetry looking thing, like the double reflection concept? Like so. All right, so then if we look at the specifics here, the integral from 0 to pi is 2. So we'd be talking about this region right there. So that actually is true. That integral does equal 2. If that's the case, though, what do you guys think the integral from negative pi to pi of g? It would be 0, wouldn't it? Because based on symmetry, wouldn't this that I'm double shading, wouldn't that have an area of 2? But because it's integrating, we're adding up a bunch of negatives, we'd get negative 2. This would be the positive 2. You add them both up to sum to be 0. So this would be 0. So there's all kinds of things that could happen with that. A general principle, if g is an odd function, the integral from negative a to a of g of x would be 0, because you're going to get some area above and some area below, and those areas based on symmetry would be the same, and they would, to whatever, to a full degree, cancel each other out if you did the full interval width. Forrest, your question. Nope. So I didn't ask what the total area was. If I said what is total area between the curve and the x-axis on negative pi to pi, then the answer there is definitely 4. I did not ask you for total area. I asked you what's just the definite integral. And on this stretch that I'm highlighting again, on this stretch, wouldn't you agree with me that every single y value on this interval, every single y value is negative, isn't it? I guess. Sorry, say again? You're kind of trailing off and getting kind of quiet, and I'm having a hard time hearing you over the fan. Could you say a little bit louder? You're talking so quiet, I'm having a hard time. Yeah, could you talk a little bit louder? I'm hearing you saying something about negative 2 and 2.
Yeah, it's supposed to be 2 because...
Isn't what supposed to be 2?
Negative 2.
Isn't what supposed to be negative 2?
The thing, like, below x-axis?
Yeah, so the area, like we're talking about this right here, right?
Yeah.
So the area is 2, but isn't, if we did the integral, I'll put it up here, if I did the integral from negative pi to 0 of g of x, isn't that going to give me negative 2?
Yeah, but you're saying, like, definite integral.
So a definite integral has the limits of integration.
It's not like definite value?
What do you mean definite value? I'm not sure what a definite value is.
Wait, I think I'm confused with the vocab, sorry.
It's okay. I'm not sure exactly what you're getting. Are you
No,
getting,
I kind of get it.
are you getting at absolute value? Maybe? No? Are we talking about this?
I don't know, never mind.
Okay. Well, keep thinking about it. I'm not totally clear.
I just kind of confused. My brain's like...
What do you, so let me ask you this. Do you agree that this answer should be 0?
Yeah.
Okay. Where do we disagree? That's where I'm just, you kept on saying, isn't this that, and isn't -2 it, and isn't 2 them, and I just wasn't sure what you were saying. I'm not saying you're wrong.
I was just like kind of having a question of that.
What's your question?
Like, but you explained it to me because like it didn't say like total. No, like the
Yeah, if I say what is total area, we would just take all the areas, make them all positive for sure, and add them up.
Okay.
But that's not what it asked. So a definite integral is not another way to ask for total area between curve and x-axis. A definite integral is saying, take all the negatives you find, add them up. Take all the positives you find, add them up, and then add the 2 of those up.
Okay.
A definite integral is simply going to sum whatever we tell it to sum. And if we tell it to sum negatives, we're going to get a negative answer. If we tell it to sum positives, we're going to get a positive answer. If we tell it to sum like negatives and positives, we're going to get a blend between the two, right? They're going to cancel each other out to some degree.
Yeah.
And in a case like this, it would cancel, the 2 areas would cancel each other out completely
Okay.
to be 0.
Yeah. I see.
That make sense?
Yeah.
Okay. Yeah, so, yeah, I just wanted to make sure I was hearing you correctly and we got it taken care of. Okay. Okay, you guys have any questions on those, evens and odds? So if I were you and I was doing some test or quiz later on and I saw, hey, I've got, G is an even function or, H is an odd function, whatever it happens to be, I would say, oh, okay, in the instructions it says G is odd. I would just go, come on. Or did my pencil just die? I would draw an odd function. That makes sense? I would sketch an odd function and say, okay, that's odd. And then I'd work with that. Or if it said something is even, I would just sketch out an even function real quick that can maybe went with the numbers, and then I'd try to reason from that. Questions?
So in like a test or quiz, would you give us one where the function is not symmetrical? It's like an even function, but it's not symmetrical over the y-axis.
If it's even, it is symmetrical on the y-axis.
But if it's like,
So not all parabolas are even.
Not all parabolas are even, true.
Because being even doesn't matter if it's symmetrical when you flip it. It's just not the y-axis.
not all
What
parabolas.
if they're like shifted over?
X minus 1.
Wait, yeah, if it's like shifted over.
Yeah.
It's
Then
not
it's not
even
even.
anymore. So for an even, I'll just use the word for this. So for an even function for a function to be an even function, maybe you remember this from pre-calc, I'm sure you do. So even functions follow this pattern. F of negative x equals f of x. So in other words, if you plug a negative number in, you'd get the exact same output as if you plug the positive version of that number in. So if I take, let's say I have f of x equals, let's just use a similar example. I'll just say like x squared minus 7. This would be an even function because if I plug in f of negative x, I get negative x quantity squared minus 7. Well, negative x times negative x is positive x squared. This would give me x squared minus 7, and now I can see that that's an even function. Whereas if I take a parabola that's been shifted maybe to the left or the right, I think is what you're getting at. So let's say I had g of x, and it was x squared minus 3x minus 7. Now this one's been shifted right or left, hasn't it? If I do this exact same test, I get g of negative x equals all this stuff, and this thing, and that, and I get positive x squared, which matches, but then I get plus 3x, which doesn't match. Therefore, that is not an even function.
Wait, so would g of x be an even degree function, just an even function, or is that the same thing?
The degree on this is 1, so no.
I thought it was just the greatest degree is the degree of the whole function.
So when you say even degree function, if you're only going to base that on the lead coefficient or the lead term's degree, well then, yeah, but it's not an even function. It doesn't fit the definition of even function.
Okay.
when you, I think I know what you're talking about. I think I know what you're talking about. Even degree, you're talking about end behavior. Even degree does this or does this for end behavior. Is that what you're getting
I
at?
don't know.
That'd be my guess. Because that's the only thing I can think of where, like, even degree on just the lead term would be something you'd look at. Because long term, both to the far right and the far left, that top degree is going to dominate the end behavior, whereas all the other ones are just going to fade to zero. But as far as being even or odd, you got to consider all. Hey, here's something that will, this is lovely. We have time to do this. And maybe my pen is charged enough, but I won't do that. I won't do it here. This is sort of an aside, and I cannot remember. We'll come back to this some point in the far off future. Remember how, listen, this, especially veterans that think, you're good, this maybe will expand your minds a tiny bit. Remember how a minute ago I told you sine was odd? And then I showed you a graph of sine, and you're like, okay, yeah, it's got the whole double reflection thing going on. Sure, sine is odd. Do you remember how the exponents, this is kind of what Aiden's getting at, the exponents, that's right, score. Practice all summer for that. You remember how the exponents should also be odd, right? So like if you have, so if you take this right here, exponent 2, and this is technically this, isn't it? So both exponents are even, therefore this was even. This, I've got an even exponent, an odd exponent, even exponent. So it's a mix, so this one's neither. You guys remember how an odd function would be like, have all odds would be x cubed minus 4x, like degree 3, degree 1, therefore odd, right? Anybody ever thought, like, why on earth is sine? Because, like, it's sine to the first, but you got to get it's not a polynomial, right? Like, how do we reconcile the two? So here's something, this is just food for thought, maybe definitely for the future, but if you're like one of those people that wants to like really explore some interesting stuff, you don't want to use your graphing calculator for this. I'm going to put this, which is bold, and I'm going to say this. It's a factorial.
I don't love this one.
Oh, I've seen this.
I put dot, 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 meaning that it just keeps going in the same pattern. I'm telling you right now that as long as that polynomial you see going off to the right there, as long as that continues on and on and on and on forever and ever and ever, those two things are equal.
Wait, so
Oh, we're going to prove it ourselves. It's going to be so awesome.
Because I'm
do it right now.
like,
This is what's called the power series, right? So I've referred to this a few
That's
times.
what you mean by
Power
that's what
series.
it's saying.
Yep. So again, we're not going to we're going to delve into this much deeper as we get into the second semester for sure. But I just want to throw this out to you as far as evens and odds go. This one, it's like not very obvious whether this is even or odd. But then when you start to look at the polynomial that actually, as a matter of fact, does equal it, if allowed to continue on forever and ever, look at all the exponents on the polynomial. 1, 3, 5, 7. They're all odd. Pretty amazing. And then if you wanted to take it another step, whoa, cosine is even, isn't it? Doesn't cosine have y-axis symmetry?
yeah, it does.
It sort of looks like an upside down parabola, like right there around the y-axis.
I bet they're going to be even.
I bet they're going to be even. You're right. This is, and you feel free to explore this on your calculator if you want. It's actually pretty fun and interesting. It takes a little bit of time because you just got to keep inputting all these different terms. You can play around with it and see all these cool patterns of behavior, and eventually it'll be perfect. At least according to your calculator, it'll look perfect. And we'll get into all the details. There's plenty of details to delve into there, including Meg's question of or Julia, whoever was how do they prove this, right? We'll do that ourselves. So anyways,
Don't get us too excited.
as long as you know how to do it, listen, as long as you know how to do a derivative, and maybe a second derivative, and possibly a third or fourth or fifth derivative, as long as you can do that, you're good. There's a lot to it for sure, but that's the mechanics of it, and we'll get there when we get there. But just thought I'd throw that out to you since we're talking about evens and odds, and it's a nice connection to the future. Say again?
I think I know how you can prove that.
That's great.
Explore.
The derivative of the sine is cosine. What you would do is you just bring
Oh, yeah, what's the derivative of x?
Take the derivative of it.
1, and then the the 3 comes down, but the 3 cancels out from the, oh my gosh, that's crazy.
Isn't that lovely?
That's so weird.
Yes. Or
I
why
find it
not?
neat.
Isn't the antiderivative of cosine just a negative sign? So as I do the antiderivative, or sorry, positive sign. So as I do the antiderivative of this, you
Yep.
see it just goes back to, right? You go term by term by term. It
That's
works out
crazy.
very lovely. We can do that for a lot of different functions. There's a lot of them you can do that with.
The factorials like cancel out.
Let's have fun with this. Here, you all. So I did this with my guys last year.
Yeah, a little bit. This doesn't look not.
What I'm about to show you, I did with my group last year. So this might be enlightening as well. Remember how the derivative of e? Oh, are we going to go 2 for 2? So
Oh, I thought you had it.
I thought I had it too.
Don't worry about it.
So y'all, thank you, Meg. We all learned last year that the derivative of e to the x is. So here's the power series for e to the x. So you can tell right away this is not an even or an odd function because you're getting both even and odd exponents. So here's what's so cool about this. Can't you take this and say, well, what's the derivative of e to the x? Well, maybe I'm not so sure, but what's the derivative of all this junk? Well, what's the derivative of this?
It'll just be the next one over.
0. What's the derivative of this?
1.
Everything, yeah, essentially gets shifted over 1, right? The derivative of this, well, the 2 would come down, the 2 would cancel, etc., etc., etc. So there's so much to explore. And the question is, why on earth, like since we already know a fair amount about sine or cosine or e to the x or other various functions, why in the world would we want to do this? And I got one really simplistic answer for you. And this is like all the reasons you'd want to do this are tied up in this. Isn't it a lot easier, whether you're talking about programming or just like human work, isn't it a lot easier to deal with a polynomial than it is to deal with some crazy transcendental function like cosine of e to the x or e to the 5x and all the associated derivatives that would go along with those? It's so much easier to say, well, I'll just use a polynomial. It's like when I refer to those, remember I've said some antiderivatives, I said, you know what, if I had to do this antiderivative, I'd either have to look it up on Google or some book somewhere, or I would just make a power series. That's what I mean. It's like so easy to handle polynomials, because all you have to do is just a bunch of power rules, and as long as you just keep that straight, you're good. Whereas if you're dealing with crazy combinations of arctangents and e's and all this stuff, it's kind of like, whoa, what am I even doing here? Why don't I just do a polynomial? It's the easy button. So if you can get there, it makes things potentially quite a bit easier. I know, you guys know Dylan Jessen?
Do I know Dylan?
So Dylan was doing this, he was doing this programming contest. I don't remember exactly what it was called, but we had to work on this thing where we had to write like a formula for a power series because he needed that power series within his little program to be able to make the program work. And so we were able to come up with this thing. And we debated long and hard whether it was like this, a recursive formula, like if that was allowed, or if it had to just be a formula where n would be allowed to proceed 1, 2, 3, 4, 5, like that kind of thing. And we came to some good conclusions, some interesting conversations for sure. But the like power series like this truly is powerful, right? It has a potential to do a lot of things that otherwise would be very difficult or maybe even impossible. And it all kind of starts with that. So
What math is he?
he's in Calc 3, I think. Yeah. All right, there's 4. We had 100% growth rate. Went from 2 to 4. Yay.
What's the highest level of math?
Are we talking undergrad? Or are we talking about graduate?
What's the highest level you can teach? Like, what's the highest level?
I could teach Calc 3 for sure.
What's the highest
Who
level
does teach
taught
Calc
at that? Like, let's say I came here.
Calc 3 is the highest right now.
Who teaches these?
They're doing linear algebra through CUCS.
So, like, there's no.
They're going to do that next semester, I think. So let's see here. Miss Albright. So Miss Albright could definitely, you know, like Miss Albright and I could certainly do like a differential equations type class. Linear algebra, I would have to do, oh goodness, I'd have to do some serious brushing up because it's literally been 24 years since I took linear algebra. So given enough time to like write a syllabus and write some ideas down and get things going, I probably could do that, but it would take some effort for sure.
But, like, there's probably not enough people.
Right now there's 2. So,
Who teaches that class?
yeah.
They teach it.
Calc 3 is Miss Albright.
Oh, Calc 3.
And then the linear algebra is through Colorado Springs CU.
So what's the difference between BC and Calc 3?
BC and Calc 3? A great question. Question of dimensions. So in BC, we learn, you guys learn about vectors in 2 space,
So is that X, Y, and Z?
and they go to 3 space. Yay.
So
So our particles in AB, our particles just did this. They went left and right. Remember, a particle is moving left and right along the x-axis, blah, 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 right? You've seen these already. So in our class, now this particle will be free to move left and right and up and down all over the place, right? And then in Calc 3, not only can it do this, but it can like come at you and away from you and up here and down here, and it's free to move in whatever dimension within the 3 space it wants. So it's 3-dimensional.
Wait, how would you find the derivative?
You just have
It's
another.
got to be done parametrically, and we'll get into parametrics this year. There's so much for us to learn.
Hey, Mr. Anderson.
Yeah.
How about Calc 4?
So Calc 4 is often referred to as Calc 4. It's really differential equations. So that's a little bit of sort of a, and
Like fourth
no.
that's the simple thing.
No, like the 4th dimension would be time, and you would even get into that in Calc 3. That would be like that parameter, like X, Y, and Z would be in terms of time. So that'd be like your fourth consideration. It's not really a spatial dimension, right? It's like time, so it's different dimension. Okay, last thing in this unit is all about trapezoids. So let's see here. I want to do this. There are going to be times, many times, when an approximation, and frankly, to be honest with you, that's kind of what this stuff is about. We're going to find that with these power series, we can control our error. We can say, is 1/1,000,000th an acceptable error to you? And if the answer is yes, we're good. If you're like, no, I need it to be 1/1,000,000,000th at most, well, then we can remedy that. We can get to a better answer. And so approximating is a useful thing. Sometimes finding an antiderivative is not going to happen, or it's going to take too long. It's going to be prohibitively difficult time-wise, and so approximating would be good. We've used rectangles in the recent past. You can also use trapezoids. So trapezoids would be our kind of our final area approximation vehicle. The challenge with this is about like orientation, I would say. So let me show you what a trapezoid approximation might look like. I could build a trapezoid on this graph. It could look like this. And then I'd have another trapezoid that would look maybe like that. And then I have a couple more. And I'm hoping that you guys would agree that these trapezoids, although far from a perfect representation of the area, would be decent, right? There's just some itty-bitty slivers of area that we're missing there. What I think is odd about these trapezoids is, aren't we used to seeing trapezoids that look a little more like this? Like this is sort of the classic view of a trapezoid, where the 2 parallel sides are horizontal, yes? And so what we've done, maybe you can see, is haven't we taken that and rotated it so that the trapezoid is sort of on its end when we look at that graph. Where this can be challenging is how we relate this with bases and heights, because we're just basically going to be finding the areas of trapezoids to approximate an area, approximate an integral. So what's the formula? This might be the biggest takeaway. What's the formula for the area of a trapezoid?
One half
I agree there's a 1/2 in there.
one half base 1 plus base 2 times height.
There we go. Okay, in various orderings there, but sure. So it's 1/2 of the sum of the 2 bases.
You know, I used that on the ACT this week. I
Excellent.
did not know the formula for a trapezoid until I took this.
I'm glad it served you. Glad it served you well. This is the way that I'll often write it. I usually write 1/2 h b1 plus b2. So what's hard about this?
Don't we use like technically the base as the height?
Yes. So check this out. Make sure you get this. Make sure you get this. This would be frustrating to be confused about this part. So make sure I'm trying to communicate clearly. Y'all okay with this being base 1 and this being base 2?
Yeah.
And if this is a right angle, then this would be the height, right? So what's tough about this, since it's been rotated, isn't this the height right here? This part of it. The height now is sort of like a horizontal measurement, and this would be base 2, and this would be base 1 if we just looked at that first one, that first trapezoid. So wouldn't the height be based on the difference in the x's? And the bases would be based on y values, which is sort of opposite of how we think about it. And that can be a challenge, especially when you're looking at a table, which we will here in just a second. So just be careful with how you do this, because I know that you can multiply and add. You okay?
Yeah, sorry. Just don't ask. Worry about it. We're good.
Well, I am worried about it.
No.
I'll ask later. Let's not make this any worse than it is. Let's not interrupt any more than we already have. Okay?
Yes.
Okay. We can talk about it later. So you're going to find in your book, like if you were to look at this in your book, we're going to be able to focus? Yes? In your book, it's going to present this thing called a trapezoid rule. It's going to show you this, and then it's going to be like all these different things, and ... Yeah, I know. So I show this to you simply to tell you this. If you were to look through your book and see the trapezoid rule, you might get confused and think, well, gosh, why are there 2 of those and 2 of those, but only 1 of those? And I don't know what to do with this. Rest assured, we will never use in our class the formal trapezoid rule, because it's been gamed by students in the past in the AP test. And so I'm just going to kind of follow suit with their gamed as in. So I've seen one actually. It's pretty impressive. A student has taken like a TI-84, and they have written a program for it, in which all you have to do is you enter in the function. So maybe you enter in, we're doing cosine or something, right? Maybe that's the curve. You enter in cosine and you say, I want to have 4 little subintervals to create these trapezoids. And you hit enter and it'll spit out amazing stuff. Like the program will output the area that you would get if you summed all the trapezoids. It'll show you all the steps that you would need. It basically is like a very primitive form of photo math.
No,
Seriously.
that is something else.
What's photomath?
I've never heard of
It's a reason that people somehow get 100s on homework and then 43s on tests. And then we have to have real conversations about it. That's usually in Algebra 1. Anyways, so anyhow, it's been gamed, right? And so let's just be honest, like if someone could write a program to do that, I would say beyond a shadow of a doubt, they absolutely know how to do this, right? The problem is, no, they're not even lazy. No, if somebody could sit down and write a program to do trapezoids, like that would take way more work than you really need to do, because that would be challenging. Hold on, listen. The problem comes up when this person is either nice enough or capitalistic enough to give away or sell their program to people that may or may not actually know what they're doing, yet when they like pop it in their calculator, it looks as if they know what they're doing, right? Because they got all the steps, they got the answer, it's lovely. Sometimes it'll graph it and show all these trapezoids, and the picture ought to look super impressive, right? But it doesn't mean you know what you're doing unless you are the one that actually wrote the program. So the ability to do that has basically been written out of the assessments, because it's not really an assessment of anything at that point.
You used to have you reset your calculator for tests?
Oh,
like that?
they have a hard time. Now, I could feel like I could do that, but like to think that nationwide, every testing center that's doing the AP test on May 14th or whatever, that everyone's going to reset their calculators, that's a pipe dream. I wish that could be true, but people will forget, or people won't. Well, now we're talking about some serious scratch, right? So, anyways.
That's the ultimate definition of it's not what you know, it's who you know.
Yeah. As far as like getting the program from someone, as far as in school goes, like, oh, you have the easy button for me? Well, I'll take it.
We're not going to use the
Right.
formal definition.
So we're not going to use the trapezoid rule, but we will use trapezoids to do what we need to do. So I wanted to show you, just straight up, I don't want there to be a big mystery here. I'll show you exactly how I would maybe assess your skills with this, as well as how the AP test would maybe assess it as well. Okay? So I'm going to skip 1 because 1 is kind of using the old trapezoid rule, and I'm just not even going to go there unless you really want me to go there and see that. Number 2, this would be an example of what you'd need to do. It says a certain function has values given below in the table. Approximate the integral from 2 to 17 of f of x using a trapezoid approximation. So this is very similar to like a right sum, midpoint sum, left sum. It's very similar to those things. I will just sketch out a graph real quick. and I'll use this partly to help. So, the 0.23 would maybe be like right there, and 3.4 would be, say, right there, so on and so forth. Maybe that's like right about there, there, and then finally 17,3 would be right about there. So it goes up, and then it comes back down, right? And so if you wanted to try to connect this with a smooth curve, you're welcome to it, although we don't know that it would look like this exactly. We could just sort of try to do something like that. Maybe it looks like that, maybe it doesn't, but good enough for the moment. So how are we going to do trapezoids? We're going to take those trapezoids and we are going to lift them up on their end, and I'll build the first one over here. It's going to be a lovely green color. Here is my first trapezoid, and it looks about like this. So how do I find the area? Well, I'm going to say the integral from 2 to 17 of f of x dx is approximately, I know it's going to be 1/2 times height. What would you all say the height for that first trapezoid would be?
No, wait, 3.5.
Oh,
One.
The first height is the difference between the 2 and the 3.
My bad.
Guys.
Well, if you average.
The difference, no, see, here's the thing. We want the difference between 2 and 3, right? If this is 2 and this is 3, and the height is something that I'm highlighting in green right there,
I
and
think I was saying the base on accident. I was flipping it. You know how it's like,
No, I did the same thing,
like
but
I
I
was
also
saying
did
like
it.
how
Same.
big it
I was
is.
saying
Like,
Hey, let's finish this one really quick. I think I know what you're talking about, but yeah. And then the bases show up in the table where? The y's. Yeah, and that's what's weird. It's like switched because we took the trapezoid and we put it on its end.
To be honest,
So this would be 3 plus 4.
3 plus
So there's my first trapezoid in green.
7.
Here's a trapezoid in purple.
No, it's 7.
Here's the second one. So this goes from 3 to 5. So I would say plus 1/2. What is my height on the purple trapezoid?
2.
2, because going from 3 to 5 is a difference of 2.
way to go, Queen.
How about
You're the queen.
the bases?
4 plus 8.
Remember when I showed you that, briefly I showed you that trapezoid rule earlier, and it was like, inside the parentheses, like base 1 plus 2b2 plus 2b3?
Yeah.
The reason why it's 2b2 and 2b3 is notice how these inner bases get repeated. The outer ones don't, but the inner ones do get repeated, and so that's why there's 2 of them. Like I said, we're not going to really do the trapezoid rule, so I'm not too worried about that.
Bless you.
Thanks, Doc.
All right, here's a third one. I'll let you guys wrap this one up after this. This is in blue. So this would be plus 1/2 times. This one goes from 5 to 8. So the height would be 3. There we go. And the bases would be,
8 plus 7.
there we go. Okay, so that leaves us with 3 more trapezoids. If you haven't already, please do try to continue to do the rest of these trapezoids and get to a finish line. Sam?
We won't have to figure out the actual number. This would be fine, right?
Well, that depends. If it's multiple
If
choice,
all of it's-
you're in serious arithmetic heaven.
If it's not, if it's tree response, this is
Yeah,
fine.
if it's an open response and you don't have to get to it to a final answer, yeah. I would not use that as an excuse to never simplify.
But-
No, there is no but. I would not use that as an excuse to say, oh, I can't add and multiply. You can.
But you can add and multiply, but you shouldn't because it might make you get it wrong.
In a free response sense, yes, I'm just saying, don't just blanket statement say, I will never do that because of the multiple choice aspect. Okay, I'm going to wrap this one up.
My answer is 787.5. You did great. You know what? Feel really
Hey, let me give you some pointers here about what I'm looking for on a quiz or a test. So if I were to ask you to use trapezoids to approximate some integral, I need to be able to see that you actually used trapezoids. Okay? So I would encourage you to, as maybe a first step, like write out that, like exactly that. I am well aware that you know what 3 plus 4 is and 8 plus 17. I know you know that. I think you do. I hope you do. However, if you start simplifying things as you go, the evidence that you used trapezoids becomes weaker and weaker, right? I want to see that you've used trapezoids to approximate all these little areas, and you've added them all up, and that's your approximation. So I would encourage you to have a step like that. Certainly we can arrive at a final answer here.
Do you have to
135.
steps?
So let's see here. That's 12. That's 37.5. That's 30. That's 27. And that's 30. Yep, 6 times 5. So you add all those up. What did you say?
135.
So 41, 53, 83. No. Yes? 841, 53. 3.5, 12. 8 plus 17 is 25. Oh, no, this is more than 37.5. No.
3 plus 17 is 30.
3
So
Or 13 plus
41
17
plus
is
60
30.
is 101.
and half of 2 is 1, so 1 times 30 is 30.
128, 140.
Wait, I am
What just happened?
This is why.
Got to be careful, Sam.
3.5. So we
Half of 7 is 3.5.
May you please not put one of these
12. Oh, it's already been written, man. 37.5. 30.
3.5 is 37.
Oh, my goodness. 13 plus 9 is 22. There we go.
Is
And that gets us to 135. Yep. Okay. So what do you do with this? So listen up. For sure on a multiple choice, you need to be able to add and multiply. There's no getting around that. For your response, certainly you can leave things unsimplified, but we want to make sure that you can do both, right? I don't want you to be unable to simplify simply because you're afraid of it. Tackle it. Hopefully you'll get it right. Forrest.
Do you actually have to write all the steps?
Yeah, so like so let's say this were a test question on Thursday, right?
wait, what if it was like in the calculator section?
Hold on. I don't know. Well, even if it was on the calculator section, here's where I'd go with this.
Write the first part, but then.
If you would just listen, I will be happy to share with you. This would be a two-pointer. Two-pointer. So point number 1. Evidence that you used trapezoids. So Forrest, I'm going to need to see the steps.
So can I write like 2 of them and then dot?
No.
And then, like,
Math is about precision as well as concepts, right?
But I did all of those steps in the calculator and then just.
What if it's not calculator active?
And I just write on paper, but it just takes a lot of time to write.
I know. I'm just telling you what I'm looking for. Like, my opinion's not going to change on this. I just want to make sure that it's clear what I'd be looking for. I'd be looking for evidence that you used all the trapezoids you needed to use and correct, everything's correct, right?
Okay.
So, yeah. Guys have questions? Questions?
It's not on this, but it's on the extra practice. Is that for quiz grade?
So, yeah, let's talk about that now. So, guys, hey, listen, please. You guys want to work on your habits. Some of you are just sort of like, yeah, we'll just have our own conversations. When we get to Unit 4, Chapter 8, if you still have these habits, think baseball bat to the teeth. It will be hard. Like you need to be, but if you're fully engaged, it's very doable. But if you're like, I haven't paid attention all that well all year, I've just been chatting most of the time, be prepared. It's going to be ugly. But if you're engaged fully and you're like with us and you're asking questions and it's going well, be prepared to do well. I'm just saying, AB veterans, I'm kind of getting the sense of you're like, yeah, been there, done that, we're good. I hope you are. I genuinely do. Unit 4 won't go that way. It's different. It's very, very different. I'll give you a preview.
Well, unit one did.
What if you saw this?
Oh, that's not.
There's an infinite area.
That's not something that
That's-
I want to think about.
We're not doing that.
Zero.
We're going to be thinking about it. Yes. So I'm just telling you right now.
I would
But
go
when I see
five.
that, I'll be able to focus. But like this, we just.
Oh, sort of like the athlete that says, "I'll screw around, I'll practice, but when the game comes, I'll turn it on."
No. Pretty much.
Yes, pretty much. Come on. Okay. What was that? What was that, Logan? Was that a good one?
It was going.
I sorry I missed that.
She goes, yeah, that's what I do, and I go, that's my
I
promise
did
in the
not say
sport.
that's what I
Oh,
Well, you said, yeah, you were extra practice.
ouch.
You answered
Okay.
in the
did. Okay.
So Thursday is your unit test. So same thing we did with the first one. So the extra practice in the notes is a quiz grade. This is just like before. And then any test corrections that you need, that's also a quiz grade. Okay, so that's obviously after the fact, whereas the test practice, the extra practice, that's before the test, clearly. So same procedure there. And that'll be the same procedure for the third unit as well. That'll be different for the fourth unit. Santi? Correct. And that's on this unit 2, the integrals and antiderivatives. Oh man, so these are tough because this is one of the ones that goes out, that potentially goes outside of our regular classroom window. So I don't.
Sorry.
I've-
Unless you want to like write this here.
I'll email me. I'll have to think about that. I'll have to look at exactly what we're doing in there. Any other questions?
We have web assignments due Wednesday, right?
Wednesday night.
Yeah, we do. Good thing I
Sounds great.
started.
Thank you.
See you guys. Have a good rest of your day.